Okay, we will go through the dimensional formula for various physical quantities in class 11 and class 12 physics. Okay, path length. Path length is dimension is length L. It is in meters. It's a scalar quantity. Displacement. This is a vector quantity. So this is x2 minus x1, difference in the distance. Okay, this is a vector. It can displacement can be 0, positive or negative. Velocity. Velocity is displacement by time. This is a vector quantity. Displacement, that is L divided by the time, so Lt minus 1. So the velocity can be average velocity del x by del t or instantaneous. When del t tends to 0, then it will become a instantaneous velocity. Speed. This is a scalar quantity. Path length divided by the time. This dimension is same as velocity, but this is a scalar quantity. Acceleration, that is rate of change of velocity, velocity by time. Velocity Lt minus 1 divided by 2, so Lt minus 2 is the acceleration. So this is average acceleration and there is instantaneous acceleration. Okay. Position vector R, that is in meters, L. Time of maximum height, that is time in seconds. Maximum height in meters, that is L. Horizontal range, L. Angular speed, omega, that is 1 by t, that is t power minus 1. R is the radius, V is velocity. Centrifugal acceleration, this is same as acceleration Lt minus 2. So this is velocity over the distance, V square by R. V is the velocity, R is the radius. Momentum, mass into velocity, mass m, velocity Lt minus 1. This is a vector quantity. Force, mass into acceleration, the m into Lt minus 2 acceleration. So this is Newton. Okay, 1 Newton equal to kilogram meter seconds power minus 2. Impulse, that is change in momentum. Change in momentum. So this unit will be same as momentum, or you can also say force into time. The same unit will come. Okay. Momentum, change in momentum is mass. Momentum is mass into velocity. Change in momentum also will have the same thing. Okay. Force into time is the same as this. Static friction. Friction is nothing but the force. So this will have the same unit as force, mass into acceleration. Similarly, kinetic friction also same. Okay, friction is a force. Work, energy and power. Work is force into distance. Force, mass into acceleration, and distance is L. So the work will be ml square t minus 2. Kinetic energy, this also will have the same thing. Okay, half mv square, this will come as the same unit, same dimension. Potential energy, that also will have the same unit. So potential energy you can also derive from mgh. Okay, mass into gravity into height. Okay, if you use this formula also, same dimension will come. Mechanical energy, this also will have the same dimension. Okay, potential energy plus kinetic energy. Spring constant, K, is force by distance. Force, you know force, the distance is L, so the resulting will be this. Power, work divided by time. Okay, work is force into distance. So power is work divided by time. Work divided by time. Okay, you can also use this F into V formula. Angular velocity is nothing but the velocity dimension, that is 1 by t power minus 1. Okay, angular momentum L equal to R into linear momentum. Okay, linear momentum LT minus 1 MLT minus 1 R L. So M L power ML square T power minus torque R into force, radius into force. Okay, moment of inertia, mass into radius square, mass M, radius L square. Okay, gravitational constant. For this gravitational force G m1 m2 by r square, if you want this constant, then Fr square by m1 m2. Force, then distance square, mass into mass. Using this you can find out the formula for the G, dimensional formula for the G. Gravitational potential energy, this is same as the energy. Okay, mgh, if you use you will get the same thing. Okay, gravitational potential from G, if you use G, using that formula from the G, gravitational constant, we can find out the gravitational potential dimension. Okay, if you use the G dimension here, you will get this. Gravitational intensity E or G. Okay, this is a vector. This is same as the acceleration. You can use G also here. Pressure is force by area. Force is mass into acceleration, then area is L square. Density, mass by volume. Specific gravity is a scalar quantity. Coefficient of viscosity. Okay, force into distance into area into velocity. Area into velocity power minus 1. Force into distance. Okay, this whole square minus 1. This is Pascal second. Okay, surface tension, force by length. Force by length. Force is mass into acceleration. Amount of substance, mole. Celsius temperature, C. Kelvin absolute temperature, K. Coefficient of linear expansion, 1 by K, that is K power minus 1. So coefficient of volume expansion, that is 3 times the linear expansion. Heat supplied to the system. Heat supplied, delta is nothing but the work. Force into distance. Okay, that is the heat is supplied to the systems, not a state variable, independent of the state. Specific heat capacity. Heat into mass into temperature power minus 1. Okay, mass into temperature power minus. So heat per mass into temperature power minus 1. Okay, this is heat, m power minus 1, t power minus 1, k power minus 1. Thermal conductivity. Heat into length divided by the area, temperature and time. Okay, area, temperature and time. Above heat into length. period t, frequency 1 by t, that is t power minus 1. Angular frequency also t power minus 1. Angular frequency also t power minus 1. Phase constant, time dimensionals. Okay, force constant k equal to force by x. Force mlt power minus 2x is L. Okay, so mt minus wavelength in meters, that is lambda L meters. Propagation constant, okay, per meter 1 by m power minus 1. Wave speed, that is lt minus 1, like velocity. Wave frequency t power minus 1. Electric charges, vector area element meter square, that is L square. Electric field, force by charge. Charge equal to current into time. Okay, current in ampere into time. Force is mlt, mass into acceleration. So that will give the dimension for the electric field. Electric flux, that is electric field into area. Okay, dipole moment, charge into distance. Charge is current into time, at into distance. Okay, this is a dipole moment. This is a vector. The direction of the dipole moment from negative to the positive charge. Charge density, linear charge density, charge by length. Charge is current into time divided by length. Surface charge density, charge by area. Volume charge density, charge by volume. Okay, electrostatic potential, EMF, potential EMF or V. Okay, that is work by charge, work force into distance divided by charge. Charge, force, mass into acceleration into distance. This is the work. Charge is at power minus 1. Okay, here so this will become t power minus 3, a power minus 1 will add. Okay, capacitance, using q by v we can find out. Q is charge, current into time. V is the voltage. Okay, this polarization, dipole moment divided by unit volume. Dipole moment by volume. Dielectric constant k, dimensionless. Electric current ampere, charge current into time. EMF, that is the voltage, work divided by charge. Okay, we already seen this. Frequency, okay, this we have seen. Resistance, voltage by current. Voltage I have already seen, current in ampere. Okay, then resistivity, R rho L by A. Resistivity rho equal to R A by L. We know all these things, then we can find out this. Okay, because resistance is here, amperes, area, and then length. Conductivity is 1 by resistivity. Okay, drift speed is nothing but the velocity dimension. Relaxation time, current density, current by the area, A by L square, so LT minus L minus 2. Mobility, drift velocity divided by the EMF, okay, electric field, sorry. So this is drift velocity divided by the electric field. Permeability of the free space. So this mu naught is the permeability of this free space, okay. So you can find out using the magnetic field, this distance, current and length. So you can mu on one side, then you take out the other side, then you can find out the formula. Scalar magnetic field, force per charge into velocity, force into charge into velocity whole power minus 1, okay. Force mLt power minus 2 given by charge is At, velocity Lt minus 1. Magnetic moment, current into area, okay. Current into area is the magnetic moment, current into area L square. Torsion constant, IAB, current into area into magnetic field. This is magnetic flux, force by charge into velocity, okay. Charge, current into time, velocity Lt power minus 1, force, mass into acceleration. Magnetization, magnetic moment divided by the volume, okay. Magnetic field strength H equal to magnetic field divided by the permeability of this free space. Magnetic susceptibility, okay. This is magnetic intensity, this is magnetization. Relative magnetic permeability sorry. B equal to mu naught mu r by n into H. Magnetic permeability, mu, okay, mu equal to B by H. Mutual inductance, okay, this is the mutual inductance. From this formula you derive for the mutual induction. This is for the EMF, and this is time and is current, ampere, okay. Time, ampere, this is for the E, we already know this. Self inductance, this is same as inductance, mutual inductance, okay, dimension. Inductance XL equal to omega L, omega is T power minus 1, okay. Capacitance 1 by omega C. See, this inductance, capacitance and impedance all will have the same dimension. See, this and this. Resonance frequency, frequency is 1 by period, 1 by T, so that is T power minus 1. Quality factor, dimensionless. Power factor, dimensionless. Dual nature. Flux constant, this is energy by the frequency, okay. Energy you already know, work done is the energy, then frequency is 1 by T, that is T power minus 1. Stopping potential, that is in volts, this is the same as EMF. Work function, h flux constant into velocity. Okay, sorry, frequency. Flux constant the frequency. Threshold frequency is 1 by t power minus 1 hertz. D Fogley wavelength, that is in meters. Atomic mass unit m. Disintegration of decay constant, disintegration of decay constant, that is t power minus 1 per second. Half life t of, that is t seconds. Mean life, that is also in seconds. Activity of radioactive sample or t power minus 1. Okay, so for each physical quantity, first you should know the definition, then based on that definition you derive the dimensional formula.